All right, and then in this last phrase, this is actually review of previously taught material in this unit, but we have a test coming up, so let's just start practicing stuff we haven't necessarily talked about in a while. So study the diagram of the dilation. Study complete. All right, name the center of dilation. So remember, like, these lines, they all converge back to where it's being stretched from, which goes to point D. So in this particular case, the center of dilation is point D. All right, scale factor, or sometimes it's called K. I like to write SF. But remember, the scale factor, calculating it, it's final over original. And just to emphasize things, the final deals with prime notation. So like, let's look from D to B prime. That's how I know that's the final one, and the original one has no primes, or these tick marks, right? This tick mark, apostrophe, prime, whatever you want to call it, that's what I mean, all right? And in this particular case, it's 16 over 20, which reduces to 4 over 5, or 0.8. All right, 4 over 5 is acceptable, 0.8 is acceptable. Maybe you just need to read the directions and tell you how to leave your final answer. And then since K is less than 1, in this particular case, 0.8 is the scale factor, we know it's a reduction. All right, reduction. All right, when K is greater than 1, it's an enlargement. And technically, I should write since K is between 0 and 1, because if it's 0, it just disappears, and then less than 0 doesn't really make sense. All right. So there's that problem right there. Number 2, in the coordinate plane, triangle hot has the vertices. So H is 2O, the lean hot, hot, hot. -3, -2, and then 2, -2. All right. Whenever I hear the word hot, I think of The Office and Michael Scott when he's banging on his steel drums, feeling hot, hot, hot. All right. So what we're going to do first is reflect over the x-axis. So we're going to do a sequence of transformations. We're going to reflect over the x-axis, and remember this axis right here is the x-axis. All right, so remember they're equidistant from the line of reflection, so bada bing, bada boom, there we go. All right, H is actually right where it was before because it was on the line of reflection. T and O are 2 below, so they're both 2 above now. Now we're going to reflect over the y-axis. All right, now the y-axis goes like this. All right, so basically what? O double prime will land where T prime was, T prime double prime will be where O was, and then H comes over here. A lot going on right now. We're focused on this green triangle. And now we're going to dilate with a scale factor of 3. And we should say centered at the origin, or centered at 0, 0. Technically, it should say that. My bad for not writing that down. But anyways, that just means, well, let's look at some stuff. All right. Let's go back, and well, H is now actually timeout. Small mistake here when I did that. Actually undo. I got a little too excited. Okay, so again, caught a mistake. O prime actually goes there. T prime and then H prime. So things don't necessarily line up exactly. Small mistake. There we go, much better. But anyways, what I want to do is H, so this is another example of why we should write things down. H double prime is at -2, 0. T double prime is at -2, 2. And O prime is at 3, 2. All right, now we're dilating by a scale factor of 3. That means I'm just going to take each and every point and multiply by a scale factor of 3, such as -2, 0 goes to -6, 0. T double prime is at negative 2, 2. Multiplying that by 3, I'm going to get negative 6, 6. And then T double prime is at 3, 2. That's going to go to 9, 6. There we go. All right. My apologies for almost messing up the reflection over the y-axis, but I caught my mistake. And then we multiplied by a scale factor of 3. And just to emphasize how this is centered back at the origin, after I multiplied all my points by 3, notice how these, I'm looking at the green and blue points, notice how they all converge back to the 0, 0, the origin. All right, so that's that right there. The perimeter of a rectangle is 80 centimeters. The ratio of the width is 3 to 5th. Find the width, length, and width of the rectangle. All right. Actually, I'm going to delete this problem. Skip. In hindsight, I don't like this problem. What we're going to go do is this problem now. A park has a triangular sandbox. Todd wants to create a smaller sandbox at his backyard, having the same angles as the park and the sandbox. Drawings of the sandboxes are shown. What is the perimeter in feet of Todd's sandbox? All right, so since he said angles are congruent, by AA, we know that these triangles are similar. The angle similarity postulate. Well, what's the perimeter of the park sandbox? Well, it's 14 plus 20 plus 18, which gives me 52. All right. Now, so we have the perimeter of the park sandbox over Todd's. I've misspelled Todd. That's embarrassing. Todd's sandbox. All right. So we know the perimeter of the park. We need to find the perimeter of Todd's. Well, we can match up a corresponding side lengths, because remember, the ratio for sides is the same as ratio of perimeters, because perimeter is just a sequence of side lengths. So since they have the same scale factor, I can set this up. I'm going to get 20t equals 416. Divide both sides by 20. And Todd's sandbox perimeter should be about 20.8. All right, 20.8 feet. And then by which theorem or postulate would determine if these two triangles are similar? Well, notice that this one, I can multiply that side by 2, that side by 2, that side by 2. So since all sides are proportional, triangle ABC is similar to triangle DEF by side, side, side. All right, side, side, side. All right, next, that's supposed to be a B right there. Looking at these two triangles, well, they're both right angles. 43, 47. Well, if I find these missing angles, well, due to the triangle sum theorem, that has to be 47, that has to be 43. So since all the angles are congruent, specifically 2, I can say triangle ABC is similar to triangle DEF by angle. All right, remember, just the angle postulate, that's the bare minimum information we need, because once you have two angles, the third angle is guaranteed to be true, so that's why we just call it angle. All right, and then this last one, that side corresponds to that side corresponds to that side. Notice how I can just multiply them by 2, thus like MN is half the length of NP. Similarly, QN is half the length of NO. So I have two sides. Now, don't you forget this. Boom. We also have angle MNQ is congruent to angle PNO because they are vertical angles. Thus, it's mathematically legal to say, well, since that's the case, these two triangles are similar by side angle side. All right, a little bit of a review. We'll do more review in the future. Have a good rest of